Hello students, I hope that you're doing great. Welcome to this video. We're talking about elements, compounds that make all matter around us. So let's start with the elements. You know that elements are organized in a periodic table. So here you can see the different elements. There are in total 118 elements found, and those elements build everything around us. So we said that most of the elements are metals. Okay, the letter H stands for a gas, which is the hydrogen. The letter C is for carbon, N for nitrogen, O for oxygen, and Cl for chlorine, Ne for neon, and He for helium. And A is the sodium, which is a metal. So everything here colored in pink is a metal. Ca, as I said, is the calcium. Fe is the iron. Cu is the copper. And remember, when you mix copper with tin, you get the bronze, which is a compound. Ag is the silver, a metal also. Au for gold. Remember that when the symbol of an element is made of two letters, the first one must be capital, the second one a small letter. Sn is the tin, Al is the aluminum. Compounds are made of elements combined together, like, for example, the carbon dioxide. When you combine two atoms of oxygen and one atom of carbon, you get one molecule of carbon dioxide. Water, for example, two atoms of hydrogen with one atom of oxygen, you get one molecule of water. Ammonia is made of 3 atoms of hydrogen and 1 atom of nitrogen. Compounds are classified into 3 big groups. We have acids, bases, and salts. So again, acids, bases, and salts. Acids are found in lots of things around us. The acetic acid, for example, here is its formula, made of 2 atoms of carbon, 4 atoms of hydrogen, 2 atoms of oxygen. It is found in vinegar. We use vinegar in food. Lactic acid is the one found in yogurt, in milk. The citric acid is found in lemons and oranges, for example. The malic acid found in apples. Salicylic acid, which is found in some medicines such as the aspirin. Oleic acid is found in olives. Ascorbic acid found in vitamin C, and carbonic acid found in soda. So these kinds of acids are found in things that we usually consume. What about bases? Bases are found in detergents and things that we use for cleaning, such as soap, shampoo, toothpastes, all kinds of cleaning things, and also in acids. Okay, so there is a difference between acids and bases. We'll see the difference in a few. Acids are found in things that we can consume, food, medicines. Bases are cleaning detergents and stuff. Acids and bases, what's the difference? So acids taste sour. This doesn't mean that you are allowed to taste them. If you don't know which acid or which base we're talking about, you're not allowed to try it by yourself, since they can be so harmful for you. Acids taste sour while bases taste bitter. Acids have a pH less than 7, while bases have a pH above 7. What's pH? pH is a chemical indicator that can indicate the amount of hydrogen or of hydroxide in a solution, and it tells. So there are indicators we will see again in a few. These indicators will tell us whether the solution is an acid or a base, or it tells us how much is the pH of a solution, and then we can classify it as acid and a base. So here is the scale for pH. It's from 1 to 14. Okay. Acidic solutions have a pH lower than 7. if I give you a solution and I tell you that the pH of the solution is less than 7, so I'm talking about an acidic solution or an acid. While basic solutions have a pH bigger than 7, higher than 7. Neutral solutions have a pH equal to 7, like water. So let's see. Here are some things that we can see around us. The gastric juices, the juices found in your stomach, the juice found in the tomatoes, the urine, okay, the pee. So those things or those materials, those matter are acidic. Why? Because they have a pH lower than 7. The pH of the juices in your stomach is equal to 2. The pH of tomatoes is equal to 4. The pH of your urine is 5. So they are acidic solutions since they have a pH less than 7. While the blood, soap, detergent, household bleach, so those have a pH higher than 7. So look, the blood has a pH of 7.4, soap 10, household bleach is equal to, the pH is equal to 12. So they are alkaline or basic solutions. However, water has a pH equal to 7. So look at this. The pH of water is equal to 7, so it is a neutral solution. Back to this, I told you, how do we measure pH? There are indicators. There are many examples of indicators, such as the litmus, for example. The litmus, the red one, the blue one, this is an indicator. Let me tell you how it works. When you place, so you have a solution. Let's take the first one. It is an acidic solution. We will take 2 litmus papers, a red one and a blue one. Okay, when you place the red one in an acidic solution, its color does not change, it stays red. When you place the blue one, the blue turns red. However, let's take a basic solution, a base. Also, we will use 2 papers, red paper and blue paper. When you place the blue paper, the color of the paper does not change, it stays blue. Why? But when you put the red one, the red turns blue. If a solution is neutral, you can use those 2 papers and place them in the solution. The color will not change. This will tell you that the solution you have in your hand is a neutral solution. So these are already prepared the papers. You can use them. They are found in the laboratories. You can use them, place them in the mixture you have or in the solution you have. And according to the changement or to the change that happens in the paper, you can tell if a solution is acidic or if it is a basic solution. Acid, base, and neutral. What about salt? Actually, when you, this is a salt, the NaCl, you know it, the sodium chloride. This is the table salt. How do we get a salt? When we mix an acid with a base, you get a salt and water. Here, what we did is that we mixed the hydrochloric acid with the base, okay, to get the table salt and water. As I said, this is the chemical equation, acid plus base. When you mix an acid with a base, you get a salt and you get water too. Here is the word equation up. So the hydrochloric acid mixed with the sodium hydroxide or combined with the sodium hydroxide will help you get the sodium chloride, which is the table salt we eat. This is the general equation. that when you mix an acid with a base, you get salt with water. This is the word equation, and here is the chemical equation. Let me go back to this, okay? So how you get the sodium chloride, which is the table salt. This is the table salt. What we did is that we mixed an acid with a base, okay? The chloride from the acid, the sodium from the base, together will combine to make the sodium chloride, which is the table salt, okay? And as you can see, one H left, one H and one O left, and this will make H2O, which is water. So when you mix an acid with a base, you get salt and water. Hydrochloric acid, sodium hydroxide, sodium chloride, and water. This is again the chemical equation showing the symbols of the reactant and results. Acid plus base equals salt plus water. So this is the general equation again. This is the word equation, and here is the chemical equation. Okay, so how do we identify a substance, whether it is an acid or a base? You use an indicator. There are plenty of indicators. One of them is the litmus, the red litmus and the blue litmus we just saw. And the color of these indicators change. It depends on the color of the on the type of the solution you have in your hands. Okay, here are examples of acidic solutions and basic solutions. So everything or all solutions, all substances with a pH lower than 7 are acids, acidic solutions, while everything or all substances with a pH bigger, higher than 7 are alkaline or basic solutions. Okay, some examples of acids are the juice in the stomach, a lemon juice with the citric acid we saw, vinegar, wine, coffee, milk are acidic solutions, while or substances, blood, baking soda, ammonia, soap, drain cleaners are basic because they have a pH bigger than 7. So this is all for now, and thank you for watching.